Okay. So I'll be back to check for people coming late in about 15 minutes. Let's get the party started. All right. So greetings, scholars. No real announcements. Let me see. So this is scholar number one. The main thing is, we're just kind of forging ahead with our information. We're going to be finishing out chapter 2 today. Working on section 2.3, dividing polynomials and the rational zero test. Okay. And a few objectives here. 1, learn the division algorithm. 2, use the remainder and factor theorems. And then 3, use the rational zero test. As usual, if you have questions, feel free to unmute yourself or type in the chat so that we can make sure to resolve the issue. And yeah, let's kind of get into it. So we have a polynomial factor. A polynomial d of x is a factor of a polynomial f of x if there's a polynomial q of x such that f of x equals d of x times q of x. All right. So long story short, what we're getting into today is like polynomial long division, similar to like regular long division. When you say one number divided by another, you see how many times does this number occur in that digit. You put the answer at the top, you multiply, then you subtract. Then, that whole procedure of long division. What we're going to be doing today parallels that just in the terms of polynomials. So we have our dividend, divisor, quotient, and remainder. Let's see it in action. Let me see if there's anything here. The main thing is that our divisor cannot be the zero function, because we cannot divide by zero. So here we actually use long division and synthetic division to find the quotient and the remainder. Okay. I think the simple thing, if I just select this and duplicate it, I guess I can just drag it from here. Here. And then let's duplicate it one more time. Done. Okay. So use long division and synthetic division to find the quotient and remainder when this dividend is divided by this divisor. Okay, let me get a copy of this guy. I'm going to do some shameless marketing for this YouTube channel that I follow. The name of the channel is called the Y-Files. They just have they're really good at storytelling. It's just a guy, he goes by the name of AJ, and his co-host is this animated plushie toy he calls Hecklefish. I don't know, but right before I met with you all, I watched this presentation they did on the electric universe. It was just so interesting to me. I was like, oh, that makes a lot of sense when you start thinking about Nikola Tesla and free energy and stuff like that. It's really interesting stuff. They just take different suggestions from the audience, and then they dig into it and research. And I think they do a presentation at least once a week or whatever. Let me copy and delete. Hopefully we got a copy. But yeah, that's what I was watching literally a few minutes before I met with you all. That's what I was wrapping up. Really interesting, but it made a lot of sense to me that at least that presentation on the electric universe. Okay, so let's do a showcase of polynomial long division. Again, if you have a brother in the living room, just tell him to hang around until the 15-minute mark, and I'll check it in a second. It's best to try to be in the waiting room about 5 minutes before the start of class, because I try to start right at the start of class so we can maximize our time together. Sometimes I'm running late, then you kind of play that by ear, but the best practice is to be in the waiting room about 5 minutes before the start of class. Because I like to try to start right on time whenever possible. So then if you get in there at 30 seconds after or 1 minute later, then you might be stuck into that second wave, right? Okay. So again, this procedure parallels long division, right? So our divisor, we're gonna have this x plus 2 divided into, do I want to do that? I could. Maybe that might look a little better. Give me just a moment. Let's do a text box. Let's do space. This paper. Let's actually just do line paper. Okay. No, what did I do? Okay. All right. So, oh, it looks weird. Single. Okay, that's better. Okay. So, okay. We have this x plus 2 divided into, we have this what? 2x to the power of 4 plus x to the power of 3 minus 16x squared. Notice we're missing x to the power of 1, so we actually need a placeholder here. So we're going to say plus 0x, because every power needs to be accounted for. And then lastly, we have plus 18. All right. Okay. So again, notice we have power of 4, power of 3, power of 2. We use a placeholder for the power of 1 and then power of 0, right? So every power is accounted for. So then the next step, so this is how we set up the structure. Again, the dividend is the 2x to the 4 expression. Sorry, yeah, the dividend, our divisor is the x plus 2. So then we're going to say the first divided by the first. So the first term from the dividend divided by the first term of the divisor. So 2x to the power of 4 divided by x is going to give us what? 2x to the power of 3. And we're going to line up our results. So I'm going to put my 2x to the power of 3 here. Okay, so first thing we did, we said first divided by first. So then next on the diagonal, we multiply. All right, so we're going to multiply. 2x to the third times x give us 2x to the 4. 2x to the third times 2 gives us 4x to the power of 3. Okay. If we were doing regular long division, our next step would be subtraction. So we're going to distribute a negative to that second row. So this becomes negative. This becomes negative. Essentially, all those signs just flip. Okay. A number plus its opposite, these guys add to 0, which is the effect that we wanted. 1 minus 4 is going to be a negative 3. So this is going to be a negative 3x cubed. Okay. So then our next term just comes down. We just bring down our next term. I actually like it right on this line paper. It's a lot easier to align things and make it like presentable. It's a pleasure. 16x squared, right? Okay. So then we repeat that process. First divided by first. So this guy divided by this guy gives us a negative 3x squared. Negative 3x squared. On the diagonal, we multiply. So we get negative 3x cubed minus 6x squared. Okay. Then we distribute our negative into that second row, because normally we would subtract, but we want to subtract the whole expression, so we need to distribute a negative. So this becomes positive. This also becomes positive. Okay. A number plus its opposite, these guys add to 0. Negative 16 plus 6 is negative 10. Okay. And then we bring down the next term. Okay. Then repeat the process, right? Negative 10 divided by x is going to be what? A negative 10x squared divided by x is going to be a negative 10x. On the diagonal, we multiply, so we'll get negative 10x squared minus 20x. Distribute our negative, this becomes positive, this becomes positive. A number plus its opposite, these guys add to 0. 0 plus anything is itself. So that's going to be 20x. Bring down the next term. Okay. And this is the last iteration. We say the first divided by first. 20 divided by x is just 20. Okay. 20 times x is 20x. Plus 40. Distribute our negative. This becomes negative. This becomes negative. Number plus its opposite as 0. That's a negative 22. This is our remainder here. Our claim is that dividend divided by that divisor gives us this quotient with a remainder of negative 22, right? And another way we can write that remainder, we can say plus r over our divisor, right? So in this case, it would be minus, our bottom would be x plus 2, and on top we're going to have the 22. Okay. I'm just being a little bit OCD, just bear with me. This time, yeah, that's good. Okay, and then we go paper. Let's go this. Okay, so that was a showcase of polynomial long division. All right. Okay, we kind of saw that process. We did it several times. We got this result. We can also do this one using a technique called synthetic division. Right. Paste. So we can do synthetic division. Let me see the time. Okay. We can do synthetic division whenever we're dividing by a linear binomial, right? So it's two terms that is linear in nature. So with synthetic division, the first step is to put our 0 of that linear binomial, put the 0 in our chair. So if we look at this linear binomial, the 0 in this case is going to be negative 2. So we put negative 2 in the chair. Next, we need to take the coefficients of our dividend. So we have our 2, 1, negative 16. Remember, we need a placeholder here because power of 1 is missing in this case. And then the 18. Okay, and we had a degree 4, so we should have 5 terms. 1, 2, 3, 4, 5. Okay, we're in the clear. And then we put this bar like this. Okay. So with synthetic division, the first term just comes down. And then on a diagonal, we multiply. So negative 2 times 2 is going to be negative 4. Vertically, we add. So 1 plus negative 4 is negative 3. Then if we multiply, that gives us 6. We add, we get negative 10. We multiply, it's going to be 20, 20, negative 40, negative 22. Okay. So, yes.
Do you mind like showing how you got these numbers?
Okay, so whenever we go vertical, we just add, right? So the first one just comes down. And then whenever we do a diagonal, we multiply. So negative 2 times 2 is negative 4. And then we add here, right? That gives us this. We just add, multiply, that's all we're doing. So then again, whenever it's vertical, we add to get this result. Whenever we're going to diagonal, we multiply to get this result. Then we add, we get this result. We multiply to get this result. Then we add to get this result. We multiply to get this result. And then we add. We just alternate between first we add, multiply, add, multiply. Again, whenever we go vertical, we're adding. Whenever we go diagonal, we're multiplying. Okay. That's a fair question though. Let me see. So because we started with the degree 4 polynomial, now we have what's called the depressed equation. In this case, it's going to be a degree 3 polynomial. It's called depressed because we dropped the degree by 1 degree. I'm about to check attendance in just a moment. So we started with the degree 4, so this is now a degree 3 squared 10x plus 20. And again, this is our remainder over here. All right, so I think we got the same result. 2x cubed minus 3x squared minus 10x plus 20, and a remainder of negative 22, right? So clearly, synthetic division is easier and faster, but again, we don't always have it at our disposal for use, right? We don't always have the luxury of using it. We can only use synthetic division when we're dividing by a linear binomial. Okay, let me check on you guys in Zoom. Okay, I got a few. Let's see. Okay. Let's see. So now, I think that's properly let everybody in. I think the numbers look good. I'm going to mark this gentleman as absent. Okay. And then let's check here. Yep. All right. Let's bring it back. So share the screen, start the broadcast. It has been behaving much better. Like in past semesters, man, it just used to throw tantrums left and right. Okay. But it's doing much better. Hopefully I'm not speaking too soon. As soon as you say something like that, then it's like, oh, you think I'm gonna do what you want me to do? So that Wi-Fi presentation I was mentioning at the start of class, it's really interesting because everybody's aware of this. We just haven't figured out how to stop this thing that happens. But it's like, you have people like Nikola Tesla who claim to have discovered free energy, right? Where we're paying power bills and electric bills, we're only doing that because that's what the collective agrees on, and the powers that be, kind of force it that way. But time and time again, you keep coming across people that figure out free energy. Like they figure out how to pull the electricity out of thin air. There was a kid, in Africa that claimed that he was able to convert radio waves into free energy. And he had a self-powered TV. And then so when he tried to introduce it to the West, they invited him over and he was apparently poisoned. Originally, I thought they killed him, but then I heard later that he survived. There was a guy somewhere here in the States, I think, that made a car that could run on water. He tested it. He was like, yeah, I can drive across the country on 1 tank of water. He was poisoned. He was meeting with some investors. And so basically, it seems like they even alluded to it in the Wi-Fi's presentation. They were like, every time somebody rediscovers free energy or, unlimited, energy and all that kind of stuff, they basically get taken out. And so it's like, it's clear that technology exists. It's totally possible. We just haven't figured out how to get past the bullies of the establishment, the people in power. They're doing everything they can to try to keep power, right? They're trying to keep us stuck on fossil fuels and not using clean energy, because the only reason we haven't used water powered vehicles for clean exhaust and free energy is because they haven't figured out how to profit off of it, right? They're stuck on capitalism, so they try to make all of us stuck on capitalism, where in reality, if they just leave us alone, we will build a Wakanda for real. If we're just left to our own devices, we would make our own electricity. We would clean our water. That's what I was thinking about over the weekend. I was watching this presentation, and this is just a random tangent. I'm just using it as a platform. But there's another content creator on YouTube I follow. He goes by Dre OG Reacts. He's always almost nightly. Now he's kind of tapered off as of late, but he posts these reactions to conspiracy TikToks. And one of the latest one he did was about, he prefaced it with, when was the last time you saw your city changing out the pipes for water? I was like, damn, you don't ever see that because they don't change them. It's been like that for like decades, right? It's the same pipes. And like the cost to change out the piping is like, astronomical, right? They obviously can't afford to do it or whatever reason they can't and won't do it. But obviously, we need new pipes, right? For clean water usage, cooking, cleaning, that kind of stuff, right? So I'm thinking to myself, I was like, okay, obviously you can't expect the city to change out the pipe so you can get clean water to everybody. They do whatever it is they do, but it's pretty obvious that you should not drink tap water, right? Because and he was showing like some of the heavy metals and impurities that's in tap water, and then like he was also showcasing how like some of these water companies, they just bottle up tap water and sell it to you, right? Like it's really wild. So I'm thinking to myself, I was like, okay, if they're not going to change out the pipe so we can get clean water, but we need clean water, then I keep coming across like presentations where people are building their own water systems. I've seen at least 3 different presentations where they collect their own water, they clean it themselves, and it's a closed system, separate from like, it's totally disconnected from the city water. I feel like if we took the time to research on how to clean our own water, what are the legalities of it? Because some places don't allow you to collect rainwater; it's illegal. But it's so weird and sinister because things that are empowering, that heal people, that like make people independent and self-sufficient are illegal. But things that are toxic and deadly, like smoking cigarettes, clearly causes cancer and it hurts people. That's legal. Feeding, like, a lot of it's illegal to feed homeless people. Like, what sense does that make? So I'm like, yo, this place is really run by like some dark people, right? Clearly how they treat people of color, they have like complete total disregard for life. It's almost like it's a gangster organization, right? The criminality of taxes, that whole spiel. When I receive money from somebody, it's taxed. That transaction is taxed. But then every time I go to spend the money, I had to pay tax. But then every time the people that I'm giving my money to, they have to pay taxes on money that's earned that I give to them. It's like every time there's a transaction, a financial transaction, we got to pay taxes on it. That's criminal. So it's so many things that keep adding up. That's like, okay, it's clear that like right now, whoever's in power, as far as government and other power elites, they're like criminal and like nefarious, right? So then it's like, but it's clear also that if we're left to our own devices, we don't need them. Like we can do this stuff ourselves. We can do our own research. We can build our own water systems. We can, I always think about getting my hands on a 3D printer. I was like, well, okay, if I can't afford to buy a mansion, what could I possibly build my own mansion? But then that also entails like owning land, looking up zoning codes, making sure you're within the code. So that you need, knowing the law, because if you can't just do it, because then it's like, if you break the law, now these organizations feel justified in coming to take your stuff. So you need lawyers, you need people that actually can study the law to defend everything. So that way you can make the law work for you instead of going against the law. That's where mathematicians and this kind of stuff that we're talking about actually comes into play. Because law is basically reading and proving things, right? Following a logical flow, right? That's what law is, which is basically mathematics. So that's the kind of stuff I'd be thinking about when I'm not with you guys. And like, I know sooner or later I'm gonna start bringing stuff to light. And if I don't do it, I'm gonna plant the seed in somebody's head that can take it and bring it to life. And so like basically what's happened is we've kind of moved into this age called the age of Aquarius, where it's the information age. You cannot stop the truth. A lot of these power organizations have had this power all this while because they were doing things in the dark and hidden in secret. And like, nobody knew what was going on. We were just being reactionary. But now, because of the way we exchange information with the internet, social media, TikTok, all this kind of stuff, everybody knows what's going on in like real time, and so these organizations, the way they used to kind of do these maneuvers, it doesn't work anymore because everybody knows. So we're not so gullible. We're not so like naive as a collective. Now, obviously we have loved ones and individuals that just want to bury their heads in the sand. all you can do is alert them once and then let it go. You cannot, you got to allow people to, you got to honor their divinity and give them, you have to honor their free will. They have a right to choose to live the life how they see fit, no matter who it is. And it's a challenge. Like I have my loved ones, parents, and whoever that's like refuses to like see these things. They don't want to research. They just kind of keep doing whatever they're doing. You can't be mad at them. You can't teach old dog new tricks, but you got to update. You have to acknowledge some of these points that I bring up. So, and if you don't be surprised when you find yourself stuck between a rock and a hard place. Like you cannot be surprised when it happens. Because like you had a warning, several of them, and you chose to ignore it. So then, but then it's like, as a truth seeker, if I belabor the point, if I like go in hard, then it's like now I'm infringing on their divinity and I'm infringing on their right to choose for themselves, right? I feel like my job is just to, hey, my research shows this, take it or leave it, do whatever you want with it, right? As a truth seeker. So that was a fun little journey on just some interesting, concepts and things that I intend to work on sooner or later. As long as I have breath in my body, I'm going to work on these things until I can't anymore. Come hell or high water. And I'm going to try to, I'm not looking for any kind of like monetary gain or anything. It would be nice, but I don't want a target on my back. And I know that the only way that this stuff survives is if enough people are aware of it. The more people are aware of it, the less likely it can be stopped. But if I try to hoard it to myself and like capitalize on it, then I become a target. I get taken out, the information gets suppressed. That's what's been happening all this while. So, that's the long and short of all of that. Okay, so back to polynomial long division. Again, we saw a showcase on polynomial long division and synthetic division. So and I think, we got the same result in either case. And again, synthetic division oftentimes is easier. Again, we really only have it to use at our disposal when we're dividing by a linear binomial, okay? So then let's look at some applications of this polynomial long division with synthetic division. If a polynomial f is divided by x minus a, then the remainder r is given by this. So this is called the remainder theorem. And there's a correlation between our remainder and evaluating a function at some given value, right? Let's see it in action. So here we're asked to find the remainder when this polynomial is divided by x minus 1, right? Okay, so the remainder theorem was saying that if this polynomial is divided by x minus 1, if we evaluate this function, basically our remainder is equal to f of a, all right? Okay, so if we're asked to find the remainder, in this case, that's going to be f of, now our a is going to be the 0. The 0 is going to be 1 in this case, right? If we look here, so when x is 1, that makes it 0. So if we evaluate this function when x is 1, that's going to produce our remainder. Now, we could try to do polynomial long division or synthetic division, then it would be all this back and forth, right? I mean, sometimes it's like preference of choice. If you want to do that, that's fine. There's nothing wrong with it. This is just an application showcasing the remainder theorem. Okay. So then if we evaluate this when x is 1, we're going to have 2 times 1 to the 5th minus 4 times 1 to the 3rd, 5 times 1 squared minus 7 times 1 plus 2. Okay. That's going to be a 2 minus 4 plus 5 minus 7 plus 2. Let me see, 4 minus 4. Okay, so it looks like these two are canceled by this guy. 5 minus 7 is negative 2. Okay. All right, let's keep going. So our claim is that the remainder, when this polynomial is divided by x minus 1, is going to be negative 2. Okay. So the remainder is negative 2. So given this polynomial, we're asked to find, now this is the reverse of the remainder theorem. Given this polynomial, we're asked to find f of negative 3. Okay. So if we were to just plug in x equals negative 3, we'll get these like large numbers, it'll be a lot of like, it'll be, our chances of making a mistake are drastically increased. If we apply the remainder theorem, we can use the remainder theorem to evaluate this function, right? So we can do synthetic division. So our 0 in this case is going to be our negative 3. Okay. We take our coefficients. Let me see. 1, 3, -5, 8, 75. Let me see. So we started with the degree 4. 1, 2, 3, 4, 5 is correct, right? Notice every power is accounted for. We have power of 4, power of 3, power of 2, power of 1, and power of 0. So we don't need a placeholder here, right? So we're good. So every power is accounted for. So then let's do synthetic division. Again, the first term just comes down. On the diagonal, we multiply. So -3 times 1 is -3. Vertically, we add. That adds up to 0. 0 times -3. Diagonal, we multiply is what? 0. And then we add, and then we multiply. We add, what is that, 23? -69. And then if we add, that's a +6. Okay. So we started with, I'll check on you guys in Zoom in just a moment. We started with the degree 4. Now for our depressed equation, we're now at a degree 3. Okay. Oh, so the remainder, right? So because this is our remainder, then our claim is that f of -3 equals our remainder, which is 6. You know, and then like, just again, kind of piggybacking off of that little discussion with like the Y files and just, you know, the interesting stuff. As far as I'm concerned, do the best you can with this academic stuff with college. Like, do the best you can. Don't take it too serious. So as far as I'm concerned, it's a game. You know, I saw somebody mention this earlier, but I think that they were accurate in what they were saying. They were like, in school, in like academia, in this field of academics, the two career paths that seem to have the highest probability of like a lot of money or guaranteed job placement or near guaranteed job placement are, I think they said medical field and engineers. Everybody else can kind of be a toss-up. Like most of society can kind of be indifferent about the other fields, but it seems like medical doctors and engineers, like computer engineers, software engineer, electrical engineer, like just traditional engineers, those seem to be the two that like have a high probability of decent job placement. Now, you know, and when I think about my experiences, I was like, yeah, because I think there's some merit to that. Like even now, I find myself like I can do engineering, but it's like because I don't have the degree, it's hard for people to give me a chance. But even though me being fully aware and knowing that I can do it, I just need to look right on paper. You know, now I'm thinking like, well, so that's just lie, you know, like say, because I know I can do it. I might need to do a little bit of research and a little bit of whatever, but that's my design as an analyst, as a mathematician. Given a problem, you know, I sit and think about it and I lay out all the openings and then address each opening. And then, you know, then we apply the suggestion and we see if we can get it to work. Right. I don't know, but it was just interesting. So I say that to say again, just do the best you can with this academia. Because then they were like, you know, then you finish school, then you have all the student loan debt, and then it's like this thing where it's designed for you to like be a cog in the wheel, where you get out of school and now you're going to be working for the rest of your life to pay off student loan debt. I'm like, I don't believe in that at all. Like, I don't resonate with that. I don't think that as a divine being, any human has to like subscribe to that. I know we're kind of pushed to that in that path by society, but I resonate more with, okay, I feel like everybody is divine. Everybody's a genius. Everybody has this talent, this gift to offer the world. Everybody has a unique piece of the puzzle that only they have, right? So as far as I'm concerned, we need everybody. And then if it were up to me, you know, I would do my best to try to stoke or like nurture that aspect of each person. So do like custom learning, like, okay, what is it that you naturally gravitate towards? So well, let's build something customized centered around that. Like I feel like apprenticeship is a little bit better. Something just, you know, instead of trying to force people to study like mathematics, this isn't for everybody. Like just let's try to get people on track with whatever it is they want to do with their existence. And let's just focus on that. I feel like people would be happier, they'd be more productive, more efficient, do better results. Instead of the way the system is set up right now, it makes people feel lesser, which is far beyond the case. I know that you guys are geniuses because I only get certain type of people in my field. Right? I know who you are because I know who I am. Right? So anyway, don't get me started. I will go and go and go. We got a solid 10 minutes. Let's try to do 10 minutes worth of this. But again, I don't mind going into these tangents because again, anything that I would say live is already available in my pre-recorded lectures. So, but yeah, if it were up to me, I would rather just build something like that where people could be happier and more productive, something like that. Okay. So I think we're good here. We confirmed, and we could take 6 and plug it into the original to make sure that it works. Plug in -3 to make sure that we get a result of 6, but we just did synthetic division. Okay. So then we have the factor theorem. We say a polynomial f of x says x minus a is a factor if and only if its remainder is 0, right? When we evaluate f of a, we get 0. But again, if we apply the remainder theorem, that's basically saying that its remainder is 0. Its remainder is 0. Its remainder is 0, right? So we say that x minus a is a factor of our polynomial if the remainder is 0. Long story short. Okay. So given that 2 is a 0 of this function, we're asked to find the remaining zeros or solve this polynomial equation. So let's start by, actually, let me check on you guys in Zoom before I get into this. I think I got everybody. I think we look good. Yeah, I think we're okay. Let me just check real quick. Yeah, we're good. So first, let's verify that 2 is indeed a 0 of this polynomial. So when we do synthetic division with 2 in the chair, our remainder should be 0. So then here's our 2. Our coefficients, we have 3, 2, -19, and 6. Notice that every power is accounted for: power of 3, power of 2, power of 1, power of 0. So we don't need any placeholders. So then if we do synthetic division, again, we should get a remainder of 0. The first number just comes down. 3 times 2 is 6. 6 plus 2 is what? 8. 8 times 2, 16. If we add, that's what? A -3, -6. Indeed, we do get our remainder of 0. Okay. Okay, that's fine. So we started with a degree 3. At this point, we're now at a degree 2. So x squared plus 8x minus 3. And at this point, we could just factor it. All right. So for instance, we're looking for 2 numbers that multiply to give us -9 and add to give us 8. I think that's going to be a -1 and 9. Okay. So then I'm going to use I guess it's called the box method of factoring. So okay. So with the box method, in the upper left-hand corner goes our leading term, which is 3x squared. In the bottom right goes our constant, which is -3. And then off the other diagonal, the off diagonal, we rewrite the 8x using the 2 numbers that we just found. So we have our -x and our plus 9x. Okay. So then, for instance, if I look at these two, what's the greatest common factor between these two? We can factor out, looks like an x. Okay. What can we factor out of these two? Looks like a 3, +3. Okay. What about these two? Looks like we can factor out a 3x. And these two, looks like we can factor out a -1. Okay. So then let me, gonna move some stuff around here. We got like about 5 minutes. I'm gonna try to wrap this one up. And again, it is a good idea to use my pre-recorded lecture for this section. It goes into some things towards the end that you definitely want to see a presentation on. Yeah. So our claim is that we can factor this guy into, we have 3x minus 1 times x plus 3. And then also to factor in that 2 that we were given. So we're going to have x minus 2 equals 0, right? So this is the completely factored form of the original equation. So then if we set each factor, if we use the zero factor property, set each factor to 0 and solve, we get x equals -3, positive 1/3, and a 2. Let me just do a scan for the remaining content or the material. Style. Okay. -3, 132. And again, we could check by plugging it back into the original, just in the interest of time. I'm going to use my prepared notes, and I think we got that right there. I'm going to have to leave this one as an exercise for you. And then I just want to mention this, the rational zero test. So the whole point of this section, we're given a polynomial, we're trying to find all the zeros of the polynomial. In other words, all the x-intercepts, the rational x-intercepts, or just the x-intercepts as we can. So what the rational zero test does, it gives us a list of possible rational zeros to choose to test from, to start from, to find our initial couple of zeros, right? So again, there is a presentation in my pre-recorded lecture. I'm going to defer you to that for this portion. And I'm going to ask, are there any burning questions before we go our separate ways? Going once, going twice. Forever hold your peas and rice. Okay. So if there aren't any burning questions, we're actually going to go ahead and end the session here. You guys are awesome. On Wednesday, we will continue this topic, but we're going to work on as many homework questions regarding this as we can. And so then what that means is that this weekend, you can anticipate exam 3 over chapter 2 to become available on Sunday. And you can earn max credit for 7 days. After 7 days, after the due date, basically after the due date, the highest you can earn is a 90. Okay, again, if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, enjoy the rest of your day. See you guys on Wednesday, same time, same place. Take care. Peace.